Hello, welcome to Program with Sam, and this is C++ Lesson 5. So today we're going to be taking a look at control statements in C++, and we're going to start by looking at conditionals. Now obviously we have access to the same conditionals that are in C, and that will sort of include if, else if, else, and then the switch statement. So let's get cracking with this. Let's start by saying Boolean, bool, my bool. We'll say it's equal to true, just for the sake of this. And we'll say if my bool is equal to true, we'll see out if statement. And then we can also add an else if. So else if my bool is equal to false, we can then say my bool, or we can say see out else if statement. And then obviously we need an else on the end, and we can just say else see out else statement. And we'll never expect it to get there, obviously, because the Boolean variable can only exist in one of two states, and both of those states are covered by the if and the else if, but the compiler will still require us to have an else statement. If we went for, say, an int, and we went 0 here, and we went sort of 0, 1, and then anything else is going to do that. That's probably a better example of showing it. And that's how you can do if, else if, and else. You don't necessarily need the else if. It'll still be the same. It's the same as C. And we've seen it before in C, Java. We've seen it before in Python, R. We've seen these kind of structures everywhere. We've also seen the switch, which we can do on my bool, the variable that we've declared. And we can say case 0, colon, and break, case 1, colon, and break, and default. And in this situation, you can really see the actual mirroring of the switch in relation to the if else. You've got if it's 1, if it's otherwise if it's 0, if otherwise if it's 1, and then the default value. So we can say see out case 1. We can say see out case 2 end all, and we can say see out case 3, and that will have the same effect. So if we go ahead and run that, what should happen is it should go if statement and case 1, if statement case 1. Lovely. And of course, as we've seen in C and Java and such, you need to make sure that you have these breaks in between your conditions. Otherwise, what will happen is it will just auto go to the next block of code regardless. So that's an important thing to remember when you're executing your code. Now, we're going to move on to control to loops and loop statements. Now, in C++, you have access to the loops that are in C. So, for instance, we have the for loop, where we can do for int I is equal to 0, I is less than 20, I++. We can then do see out I, like so. And then at the end, we can put a see out end all after we've done 1 to 20. So if we run that, it'll do the my bool bit, but then it does all the numbers from 0 to 19, obviously, because we start at 0 and it's less than 20. We have access to the while loop. So while, if we say int j is equal to 0, while j is less than 20, see out j++, and a space, and that should do exactly the same thing. We just need the see out end all. And this should do exactly the same thing as the previous for loop, because it's essentially saying it's going to keep on executing this code whilst j is less than 20, and every time we increment it. So if we didn't increment it, it would be 0, and it would just infinitely output zeros every single time. And we also have access to the do while, which is where we have do we specify the condition down here. So while j is less than 20, so or we can say j is back to being equal to 0. So then what we do is we can just copy this line of code in there. And then, what's it not happy with? Oh, that's why it's not happy, is because it didn't have a semicolon on there. But then if we give this a play, it's done the same thing again. Now, what is the difference between a while and a do-while loop? Well, we've actually examined this before on the channel and in the blog. So, but for the purposes of this tutorial series, we'll go over it again now. So the key difference between a while and do-while loop is the evaluation. The evaluation of a while loop is done even before the loop starts. So for instance, if we do j is equal to 20, it will not execute this while loop because j is already equal to 20. It's not less than 20. So we're only going to see two lines. There is the line that should have the while loop in, but because it evaluates the condition first, it's not there. Now, if we say it's 20 here, it should run at least once and give us 20. And the reason for that is because it's evaluating the condition after we've actually run the first iteration of the loop. And that's sort of like the key difference between while and do while. Now, obviously, thus far, we've just sort of been looking at these loops and these very traditional style where you have your conditionally stuff and your for, but C++ is object-oriented. So one of the things we can do is actually iterate specifically over a collection. So let's say that we have an int array in R for is equal to, and we say 1, 2, 3, 4. One thing we can do is we can iterate over that, and it's basically the same as Java. We can say int I in array, and then we can say cout I space cout end all, and yeah, we can iterate over objects within a collection in the same way we do in Java and C# and all these other object-oriented languages. That's a nice nifty addition with C++ that you're not necessarily able to do with C. And this will work for any sort of collection. So vectors will work, and obviously arrays will work, all that kind of stuff. And it's quite a useful tool to have in your arsenal. So the last thing to talk about here then is GOTO. Now, I've talked about GOTO before in the C series, funnily enough. And GOTO is something that you shouldn't use. It's actively discouraged for you to use in your programming because it is bad practice. GOTO essentially allows you to create a label which you can then have the code jump to, and it will continue executing the code from that label downwards. In a sense, that they come from this idea that you can then have a GOTO statement that takes you back up to the top of the code and rerun it. And you can essentially do a loop that way, theoretically. And to be fair, an example of this is kind of the switch statement, because it tests the condition and then executes there. If it doesn't, it goes to the next label. But if you do this condition and it tests okay, unless you break, it's just going to keep on running through this. And it's a similar thing with GOTO, is it will go down. But one of the main reasons that using GOTO is discouraged is because it allows you to jump outside of the scope. And what that means is that the variables that were in scope are no longer available to you, and it can then cause errors and bugs in your actual application. So we're not going to show you how to do it. I think I did that in the C series, but it's just worthwhile drilling in the fact that you should not be using it anyway. You've got everything you need to control the flow of an application here. There's really no need for anything else. And that's it for this time. Next time, we're going to be looking at creating classes, instantiating objects of those classes, and how you handle garbage in C++, because it is a bit different to Java and so on. If you'd like to follow me at ProgramSamBlog, or follow the blog directly at programwithsam.code.blog, that would be much appreciated, and I will see you in the next one.